Hi there, grade 10. So this is the video for Unit 3, Lesson 4, or as I call it on your calendar, 3.4. Okay, so this is a lesson on multiplying polynomials. So we're going to actually take a break from those factor trees for a while that we've been doing the last 3 lessons and focus on something totally different. So you guys actually learned all about polynomials in grade 9. So I'm going to do a little review of something you learned in grade 9. The first thing we're going to talk about is simplifying polynomials. So your grade 9 teacher would have taught you that we can combine similar terms. So in this big stretch of expression of terms here, 3x minus 4y plus 5x minus 2 plus 7 minus y, we're going to look for similar terms. Now, similar terms are anything with identical variables. So if I look at 3x right here, there is a similar term and it's the 5x because they both have x's. Okay, then if I look at the negative 4y, do I have another y anywhere? Yes, I do, at the end. So they're similar terms. And then these two guys that are left over, they're actually similar terms as well because they have no variables at all. They're called constant terms. So we're allowed to combine those guys as well. So if I start with the similar terms 3x and 5x, all I do is look at the symbols and do what it says. So I have 3x to start with, and then it says add or plus 5x. So 3x plus 5x becomes 8x. Try that again. 8x. Okay? Then if I go to my 4 or my 4y and negative y, you have to really be careful and look at the symbols. That 8x still looks really ugly. I don't know why my pen drags sometimes. 8, there we go, x, that's better. With the y's now, be careful and look at the symbols. So you start with a negative 4y, so negative 4, and then it says minus y. But we have to remember that there's always imaginary ones, okay, in front of a letter. If there's nothing written, it's a 1. So this is actually saying negative 4 minus 1. So if you have negative 4 and then you take away one more, you're at negative 5 now. And finally, these two numbers that are in blue here, again, make sure you look at the symbol. You start with negative 2, right? And then you add 7 to that. So negative 2 plus 7 is positive 5. So that's how you would simplify that expression. Just look for the similar terms and tally them up. Another thing I want to review is multiplying, okay? So here I have what's called a monomial. That might sound familiar to you, okay? And it's multiplied to a trinomial because there's 3 terms in that bracket. 3 terms means trinomial. So what we have to do is we take this 4x squared and we have to distribute it and multiply it to each term. Now, something we have to also remember is that when we're multiplying, we add exponents. So I'm going to write that over here. When we multiply, we add exponents. Okay, so when I do the multiplication here of the first term, I have 4x squared y times 4y squared x. So first you're just going to start with the numbers. It's just 4 times 4. That's easy, 16. Now we look and we add the exponents. So if I start with this x squared, I look for the other x, and we have to remember there's actually a 1 on that x, okay? So when I count up all my x's, I have 2 over here, 1 over there, I have x cubed. Then the y, same thing, I'm not done. I have 1 y out front, and then I have y squared over here. So 1 plus 2, I actually have y cubed. So let's move on to the next one. 4 times positive 3 is positive 12, easy peasy. And now we add up our exponents. Remember, there's ones on there. So when I add up my x's, I had 2 out front from the x squared, and then I have 1 inside the bracket. So 2 plus 1 is 3. And same thing with the y's. I had only 1 out front and 1 in the bracket. So 1 plus 1 is 2, and it becomes y squared. And finally, you're multiplying this 4x squared y to a negative 2. So 4 times negative 2 is negative 8. And then because there's no exponents or no variables attached to the 2, there's no letters, we have nothing to add. So the x squared y just remains the same. It wouldn't change. So that's a little refresher of multiplying. So you multiply the big numbers and you add the exponents. And that's going to be really important as we move on. So this is getting into what we're doing today now. So here, I want you to multiply x minus 4 to x plus 2. So you have one set of brackets out front. That's called a binomial because there's 2 terms in it. And then it's multiplied to another binomial in another set of brackets. So the way we do this is we take the first term in the first bracket, the x, and we multiply it to each term in the far bracket. And then we move on and we take the negative 4 and multiply the negative 4 to each term in the far bracket. So we're actually going to end up doing 4 multiplications. So if I start with this first one here, x times x. So when we're multiplying x's together, we add the exponents. Whoops, I want black again. We add the exponents. So each of those x's has a 1 on them, right? There's always a 1 there. 1, 1. So we just add them. Then I take this x again, and now I multiply it to that far positive 2. So x times positive 2, or x times 2, just becomes 2x, okay? So when you're multiplying an x and a 2 together, we just rewrite it as 2x. We always put the number out front. Okay, so now I'm going to move to the ones that are in red. So now I'm multiplying negative 4 to x. So negative 4 times x, we just smush them together. It's negative 4x. And then my last one would be the negative 4 times the positive 2, and negative 4 times positive 2 is negative 8. So now, we always have to simplify if possible. So once we do our multiplying, we have to look and see, are there similar terms? So my front term is an x squared. There's no other x squared in the polynomial, so I know I have nothing to add it to. So I know in my final answer, I'm still going to have an x squared. It didn't change. But then my next term is an x, a 2x. Do I have another term in here that's just an x? Yes, I do. These guys right here are similar terms because they're both x's. So what I do is I look at the front numbers. So I have a positive 2 minus 4. Well, positive 2 take away 4 is negative 2, and it just still remains an x. You don't add the exponents here because we're not multiplying anymore. We're just simplifying. And then that negative 8 tacked on the end has nobody to join with it, so it just stays a negative 8, and that's the final answer. Okay? All right, we're going to go over to B here, which is the same idea. So I'm multiplying a binomial to a binomial again, but the terms just get a little bit more complicated here. So the first multiplication I'm going to do is the first term in the first bracket to the first term in the second bracket. So you multiply the big numbers out front. 2 times 2, that's easy, it's 4. Now you have to add your x's up. So you had 2 there, 2 there. You have x to the 4. Now I'm going to take that 2x squared and multiply it to the other term, the negative 7. So 2 times negative 7 is negative 14. And then there was no x's on that 7 to add it with, so it will just stay in x2, x squared. So I'm done with that term, and now I restart with the negative 4. So negative 4 times 2, that gives me negative 8. And then again, there's nothing to add with that x squared, so it stays x squared. And finally, I'm running out of pen colors. I'll do blue. Negative 4 times that negative 7. Negative 4 times negative 7 is positive, positive 28. So be careful with your symbols, and there's no x's at all. So there's your four multiplications, and now you ask yourself, are there any similar terms? So my first term is an x to the 4. There are no other terms in this expression that have a 4 and x to the 4, so it doesn't change. Now, if you look at the two guys in the middle, though, they're both x squareds, so they're similar terms. A metaphor I sometimes use is think of family members with the same last name. I want you to think of these x squared and x squared here as last names, okay? So I would consider these two terms in the middle family members because they have the same last name. And I know all family members don't have the same last name, but just for this metaphor, we're going to pretend they do. So because these two terms have the same last name of x squared, we get to reunite those family members and bring them together. So negative 14, you have to bring that negative with you. It's negative 14 minus 8. And negative 14 minus 8 is negative 22. And then their last name doesn't change. It's still x squared. And then that positive 28 on the end has nobody to join with it, so it just stays a positive 28. And we're done. Okay, next one. This looks a little bit different. I just have one binomial, 8x cubed plus 2y to the 8, and then that's all in brackets squared. Now, what a lot of students are tempted to do is just to bring in that 2 and square each term or multiply each term by 2, and that is very, very, very wrong, okay? As you guys know, if I have something like 5 squared, that means it's 5 times itself, right? So same thing here. I am saying I want this bracket times itself. So it's really going to look like 8x cubed plus 2y to the 8, close bracket, times itself. So I rewrite it. And that's what the question's asking you to do, okay? So I'm going to start to go a little bit faster on this one because it's similar to example A and B. We're multiplying two binomials. You start with the first term and multiply it to each term in the far bracket. So 8x cubed times 8x cubed would be 64x to the 6. Then multiply it to the far guy. 8 times 2 is 16. Now, if you notice here, I am multiplying x cubed with a y to the 8. We cannot add those together. We can't go 3 plus 8 is 11 because one's an x and one's a y. They're totally different. It's like apples and oranges. So all we do is just write them both down beside each other. They just join together. Okay, so now I restart and I go 2y8 times 8x cubed, and that is 16. Now, again, I cannot add those exponents together, so I'm just going to write what I have. I have y8, x3. I just smush them together. And finally, the last multiplication is 2 times 2, which is 4. And then I am allowed to add those together, y8 and y8, because it's the same letter, so it becomes y16. Okay. So let's look at this and ask ourselves if we have any similar terms to simplify. My first term is 64x to the 6. Do I have any other terms that have an x to the 6? No, I don't. I rewrite it. Now, look at the two terms in the middle. 16x cubed y8, 16y8x cubed. In class, I would ask you, are those similar terms? And I would guarantee I would have people nodding their head and some people shaking their head. Yes, they are similar terms. I just have the letters flipped around, but if you look closely, each term has an x cubed and each term has a y to the 8. They're just in a different order, and that's okay. They each actually have the same thing, just in a different order. So we are allowed to combine those. So 16 plus 16 is 32. Now at this point, you have an option. You can either write it x3, y8, or you can write it y8, x3. Both of those matter. So I'll kind of write both of those options in. You can write either one of those. And then the positive 4y16 on the end. won't change. I just want to let you know of something that in the textbook, sometimes they reorganize the terms. So for example, the textbook might write this with the 4y16 out front, and then they might put the 32 in the middle, and then they might put the 64 on the end. And that's okay. They're just ordering them from highest exponent to lowest exponent. That's called decreasing order. And so if you look at your textbook and it's totally rearranged, that's fine, as long as you see that you actually have the same 3 terms as they do, just in a different order, you're good to go. Okay, so don't worry too much about that. Okay, this one right here. So as you can see, I have this first bracket, 2x minus 1, all squared. So I just finished explaining that that means times itself, right? So, oops. So I'm actually going to rewrite it as 2x minus 1 times itself, and then I have 3x plus 2 as well. Okay, so this guy here, holy smokes, what do we even do? What we do is we take the first 2 binomials and multiply those together and ignore the third for now. We're just going to leave that 3x plus 2 out in the dust until we're ready for it. So just like normal, whoops, you guys know what to do here. 2x times 2x, 4x squared. Then 2x times negative 1, negative 2x. I move on to negative 1 times 2x, that's negative 2x. And finally, negative 1 times negative 1 is positive 1. So there you go. I just multiplied this guy to both and this guy to both. I'm going to put that in brackets again because I still have to multiply it to another binomial. We can't forget about him. But before I multiply it, I'm going to simplify the 2 middle terms. So this actually becomes 4x squared, and then negative 2x and negative 2x are similar terms. So negative 2 take away 2 becomes actually negative 4, and then it's multiplied to 3x plus 2. So now you have a trinomial, 3 terms out front, multiplied to a binomial. All you do is take the first term and you multiply it to both terms in the far bracket. So 4x squared times 3x becomes 12x cubed. Again, we add the exponents, and there's a 1 on that x. Then 4x squared times 2 becomes 8x squared. No x's to add. Then we move on and we do the same thing with the middle term. Multiply the negative 4x to each term. So negative 4 times 3 is negative 12, and between those 2 terms, I have x1 and x1, so I add them up to x2. And then again, negative 4x times positive 2 is just negative 8, which is 1x tacked on. And finally, I have positive 1 multiplied to both terms in that bracket, but multiplying anything times 1 doesn't change it, so it'll just remain 3x and 2. So now at this step, we look at all of our terms and simplify if possible. So I always look at the first term, it's 12x squared, 12x cubed, but there are no other x cubed terms, so I write it down as no one to add up with. Then I have an 8x squared and a negative 12x squared. Those are similar terms because they're both x squared. So you start with positive 8, but then you subtract 12, so it becomes negative 4x squared. Then you have a negative 8x and a positive 3x. Those are similar terms as well because they're both x's. So you started with negative 8 and then you're adding 3 to that. So negative 8 plus 3 is negative 5. And again, the x's don't change because you're just simplifying. And then that positive 2 on the end has no friends to play with. So he just sticks around as a positive 2. And there's that one. Okay, I'm going to just do E. I'm going to skip F because if you look, D and F are actually very similar. In D, we did a trinomial multiplied to a binomial. Here, it's the same thing, just flipped around. A binomial multiplied to a trinomial. So you would just do the same thing, multiply each term in the front bracket to each term in the second bracket, and it would turn out to be similar type of question. But I'm going to do this guy here. So this is where the meat and potatoes really are. So as you can see, I have two binomials multiplied together out front, and we've done that a lot. But then I am making you minus another two binomials multiplied together. Because remember, when you square something, that means times itself. So this question is actually saying 4s plus 6 times 3s minus 4, whoops, minus, and then 3s plus 7 times itself. So that's what the question's really asking, right? So it's like there's two parts to the question, the left-hand side, the right-hand side, and then we're going to minus the two answers in the end, okay? And I want you to watch this question till the end because there's something funky we have to do with that subtraction in the middle. So when I multiply these first two binomials out here, 4s times 3s is 12s squared. 4s times negative 4 is negative 16s. 6 times 3s is positive 18s. And 6 times negative 4 is, negative 24. So that's the multiplication of the first two binomials. And then I want you to keep both of your answers in brackets just to kind of keep them separated still, okay? Then I'm minusing, and now I'm going to do the second set of multiplication. So 3s times 3s is 9s squared. 3s times 7 is positive 21s. I move on to this 7 now. 7 times 3s is 21s. Well, that was weird. And then the last multiplication is 7 times 7, which is 49. Okay, so now what I'm going to do is I'm going to simplify each bracket. So if we look at the first bracket, 12s squared joins with nobody in that first bracket, but then these middle terms are both s's, so I can combine them. So negative 16 plus 18 is positive 2s, and that's a s, not a 5. Let me try that again. S, and then negative 24 has nobody to combine either. So there's the first multiplication all simplified, and then we're minusing, and we're going to do the same thing here. So in the second bracket, 9s squared has no one to join with, but then again, I can combine those two guys in the middle. 21s plus 21s would be 42s, and then that 49 tacked on. Okay, so now we have to subtract this whole second bracket from the first bracket. It's like this negative gets fed in to every single term. And that's why I had you keep the brackets around, because usually when we have brackets, we think of distribution, these arrows. And if we didn't have the brackets, we would actually forget to distribute that negative. So I'm actually going to rewrite this question one more time where I distribute the negative. So the first bracket won't change. But now the second bracket, that negative gets fed in to every term. It's like I'm multiplying every term by a negative. So this positive 9 that was in the bracket becomes negative 9. And then that positive 42 becomes negative 42. And then that positive 49 becomes negative 49, okay? If one of these terms in this bracket was already a negative, for example, and you brought in the negative, well, then the two negatives would become positive. So essentially, every symbol in the bracket just gets flipped when you distribute a negative in. So that's essentially what subtracting in this case means. You send the negative into each term in the bracket that follows that negative, and it changes the symbols. So now we have 6 terms here, and we're going to ask ourselves, can we simplify any of them? So if I look at my first term, I have a 12s squared, and I have another s squared right there, so I can combine those. I have a 2s, and then I have a negative 42s, so I can combine those. And then I have a negative 24 and a negative 49, which are just lone numbers. They can combine as well. So When I combine the first terms in red, 12s squared minus 9s squared. 12 minus 9 is 3s squared. One final reminder, don't change the exponent on that s. You only change it when you're multiplying. We're just simplifying here. Then positive 2s minus 42s. So 2 take away 42 would be negative 40s. And finally, negative 24. So always remember to bring the symbol with you, that's in front. Negative 24, and then you take away 49 more. You're going to be super negative. You're going to be at negative 73. Okay, and there's the final answer for that tough question. So that's essentially as hard as a question can get. Okay. So again, you can watch this video as many times as you want to replay a question if you want to hear me explain it again. That's the beauty of a video. But if you're good to go, the assignment's listed right there. It's a textbook assignment, 5, 8, 15. And for 21, you only have to do questions C, D, and E from 21. All right. So for kids who are doing this at home, remember that you actually technically have 3 days to hand this in. It won't be due for you tomorrow because that's only 1 day. And then the following day you're at home again, so it would be due the next day after that. Okay, good luck with the assignment. Check you later.